Okay, so hi everyone, and welcome again to this webinar. My name is Giuseppe La Rocca, and I'm Community Support Team Leader at EGI Foundation. And today, during this presentation, I would like to briefly introduce you what is EGI and what EGI does for supporting advanced computing. And together with me, there is Giri, Adrian, and Clara from CESNET, because after my short introduction, my colleagues from CESNET will provide you more additional details on how to access and use accelerated computing in EGI. So this is, in a nutshell, the agenda for the meeting today. So I will start with this intro, and then I will hand over to CESNET people. So for the introduction, I like to start with this slide presenting the WCG experiment. I don't know if you are aware or not, but the mission of this experiment is to provide a federated and global infrastructure connecting different advanced supercomputers to support energy physics experiments. This is a dedicated setup that the CERN established for supporting the requirement of this community. So the federation that we are talking about, the EGI Federation, is quite similar to this setup offered by CERN for the WCG experiment. We started around 2010. So the EGI Federation is also composed by a federated resource provider. Most of these providers are located in Europe. But over the year, EGI also established international collaboration with other peer infrastructure in the US, Latin American countries, Africa and Arabia regions, and also in Asia-Pacific countries. When we start in 2010, of course, the solution and the capacity offered by the Federation, EGI Federation, was allocated for supporting energy physics community. But over the year, we grow up, we try to support additional communities. So now we have more than 250 communities that are accessing and using the resources allocated by EGI. We are supporting astronomy, astrophysics, but also structural biology communities, and many, many others. When we started in 2010, our vision was to offer seamless access to the services and the resources offered by EGI for helping the different researchers to support their day-by-day work. To achieve this mission, to achieve this vision, the mission of the Federation is to deliver open solutions in order to enable advanced research, cutting-edge research, innovation, and knowledge transfer in Europe. To support this mission of the Federation, of the EGI Federation, it was established a foundation, what we usually call here EGI Foundation. This is a non-profit organization established by under the Dutch law, with a clear mandate for the community from the Commission to support, to maintain, to coordinate the Federation on behalf of the different member states. So up to now, EGI is composed by 28 different participants from 22 different countries. We have 5 different international research organizations. And also CERN is part of this federation. We distinguish between full participant and associate participant. The orange one are the associate participants, which are just to distinguish the ones that are joining the federation with a sort of lightweight membership. So recently, this October, we welcome a new partner. We have a new National Bioinformatics Institute from Sweden that joined the federation. So we will update this diagram very soon. So we have now 29 different participants, basically. So the overall federation is organized in 3 different layers, as you can see here. So we have the foundation, that is the coordination body. that basically talks with the different members of the EGI Federation. These are basically the partner of the Federation that are offering IT resources, capacity, but also technical expert and knowledge in order to allow the different researchers to fully exploit the solution offered by the Federation to support advanced research. The foundation, together with the members, the partner of the EGI Federation, and all the community that we are supporting, including all the organizations that are contributing to implement the EGI vision, is what we usually call here EGI community. As EGI, we provide solutions for different stakeholders. So, of course, one of the main stakeholders are represented by the research communities, research infrastructure, but also projects with the international footprints. We are also offering a solution to target the business. So we have a solution for the SME. There is in particular, EGI launched the Digital Innovation Hub, which is a program for helping the community, this business organization to test the infrastructure before to do the investment. And of course, we have a solution to maintain the federation up and running. So provide here a solution like the help desk, which is the portal where the user can submit a request for support, or the accounting, the monitoring to monitor the current usage of the capacity offered by EGI. Today, of course, we are focusing on the services for researchers because this is the main target for this meeting today. So what you see here is a screenshot of our service catalog and the different service offering to support advanced research. EGI is offering compute services, sorry. These include not only HTC, but also cloud. We also provide a solution to facilitate the orchestration of compute jobs. So here we have this workload manager based on the rack, which facilitates the execution of large amount of batch jobs in EGI infrastructure. We have a storage and data solution, security identity, training, and also the additional solution like Jupyter notebooks based on Jupyter apps to facilitate the data analytics on big data set. So these are the offerings. So if you go in the service catalog, you can click on each of these services to get more additional information. And of course, this is the link from where you can get additional documentation. For this meeting, we are going to focus on the compute part. So here, very briefly, I'm going to present the status of the HTC and the Cloud Federation. As you can see here in the top of this slide, you see the status of the federation, HTC Federation, with all the different providers. As I mentioned before, most of these providers are available in Europe, but there are also additional resource providers in different regions, thanks to the collaboration established by EGI with the additional peer infrastructure, as I mentioned before. The cloud infrastructure is quite dynamic compared to the HTC infrastructure. We have at the moment 28 cloud providers, most from Europe, but recently we managed to federate 2 additional providers from China and South Africa. And we are also trying to federate also business cloud like T-System. So we already started the discussion with this partner in the context of EGI ACE. This is a flagship project of EGI, and hopefully we can include this additional cloud provider in the coming months. So all these cloud providers are contributing to the vision that I mentioned before. So they are offering a capacity for supporting the scientific needs of different communities. These providers are not only offering a cloud resource, but also accelerated computing, so GPU cards. We have 4 different providers of the federation. You see here the host name of this provider. We have CESNET, another provider from Slovakia, one from Spain, IFCA, and this is from France. you see the different configuration of the different accelerator card offered and the different access mechanism, access policy, because each of these provider can offer this capacity with a different access policy. Very briefly, we've offered these 3 different types of access policy. We have a wide access, so we offer for specific types of services, we offer some pre-configured setup for helping every user to access and use our solution. One example is represented by the EGI notebooks. This is a solution, services operated by EGI. For all the user, the access is free, so we don't provide any particular restriction. Each user has a dedicated setup, so we are not offering a lot of capacity. If there is a community requesting a specific resources, a specific setup, we can have a dedicated configuration, and for this we need to have a technical discussion. We have other possibility is a policy-based access. So in this case, the access to the capacity and the services can be discussed together by either the EGI Foundation or also the resource provider. So for example, some provider receive fundings from their national agency to support specific communities. So in this case, they are able to support all the other the communities, for example, the bioinformatics communities requesting access. For other, we need to discuss the different policy mechanism. And the last possible access policy is the market-driven. So it's a sort of pay-per-use model that we can offer. So because sometimes we have a project, H2020 project or a research infrastructure that can pay a fee for using one of the solutions offered by EGI. And okay, these are the last 2 slides to summarize a bit EGI with a couple of numbers. So we are serving more than 78,000 of users from different disciplines. We have 28 plus now 1 council member. Thanks to this collaboration, we are sponsoring. So the solution offered by EGI are contributing to support the research activities, and this contributed to the submission of different publications. So there are more than 1,200 publications sponsored by EGI in 2021. More than 50 million are the cloud computing capacity consumed by our user, and there are even more HPC CPU hour consumed by our members. And okay, if you want to get more information about EGI, please have a look to the publication. And also, this is again the link to the service catalog, from where you can get more details about the service offering. And this is the official mail list in case you need a dedicated support. So feel free to contact us, writing to support@egi.io. And this is my last slide. So now I would like to hand over to Giri and Adrian. So let me stop my sharing. And guys, now, can you?
Yes, so I will share my screen with you, okay?
Great, okay.
Great, so, and click on it. So can you see it?
Yeah, we can see your presentation, yeah.
Okay, so here is start. So I'm ready, so yeah,
Yep.
Can we start?
Yeah, ready when you are.
Okay, so good afternoon, ladies and gentlemen. My name is Jiří Vorel, and I'm member of Metacentrum User Support Working Group, and I've been asked to tell you something about how to use GPU nodes on Metacentrum. So I think we can start. And I would like to start with it that, as Giuseppe said, that the presentation will be available after this meeting. So on my slides, there is plenty of useful links to our documentation, so you can check it later on. and I believe that you can find a lot of interesting information which will not be say here. So I will start with the short and brief general information what Metacentrum is. Metacentrum is basically it's a Czech national grid infrastructure provided by CESNET. It's mainly dedicated to research organizations and users typically from universities, academy of science. And Metacentrum is completely free of charge and of course is dedicated to non-commercial research. But we are able to grant access even from partners, for example, partners from outside of the Czech Republic, and as it makes sense, even they have to do like a non-commercial academic like research. Metacentrum can offer you very interesting computing capacity. Right now, it's about 45,000 CPU cores in many different types of servers, from very small servers with up to 32 CPUs and some very special servers with 6 or 10 tera of RAM memory. Our grid infrastructure is operated by PBS batch system, so it means that you have to write some script and submit it into the batch system, and everything is running on a Linux-based system, so mainly Debian 11. Some machines are running on a CentOS 7. Especially everything is available via command line interface, but we are able to run even, if you prefer it or if you need it, even a graphical user interface. So it depends what you need, what you want to do, and what is better for you. So I would like to point it out some like interesting link here. Here you can find some basic information from beginners. I would recommend it to you to check it and see and get some like a general overview how to use Metacentrum more deeply. What is it and how to use it? And if something will goes wrong or doesn't make sense or you are lost or everything, don't be hesitate to contact us, send us email to our Meta support group, and we will help you. It's not a problem. So that's why we are here for you. So I would like to start with some very brief introduction how to reserve some hardware resources, especially GPU cards on our GPU nodes. So let's take a look. Let's assume that you check out documentation and you have some general overview what Metacentrum is, and you have to find out that there is something what we call front ends. Front ends are mostly very small virtual machines which purpose like gateways to the entire grid infrastructure. Yeah, these machines are mainly dedicated to that you can log on them and write there your shell scripts for batch jobs. You can check your data. You can check if we have applications which you need, if the version is correct, if the, I don't know, compilation was fine, everything's neat. But please, it's quite important, and the users sometimes don't accept it. Do not use front ends for long and demanding calculations. You can something download there, something extract it. Oh, yeah, that's completely fine. But run some very long calculation is not really fine. So we have plenty of storages, plenty of home directories. Even I think we have 10 front ends. So again, there are 2 links, so you can see more information about it. And last thing, what I want to say that front ends are available via classical SSH protocol with your username and password. And because you have to generate a Kerberos ticket, we do not support SSH keys. So every time use your username and password if you want to log on some front end. PBS Pro will reserve some like hardware resources instead of you. You have to specify what you need. So typically, how many cores you want, if you want GPU cards, how many, 1 card to up to 4 card you can guess. How many RAM memory do you need? Scratch directory if you want. You should want it. And wall time. Wall time, it means how many hours do you want for your calculation. All these parameters are via QSub command given to the PBS server, and PBS servers reserve it as I said. There is plenty of options which you can ask, which you can reserve for your calculation, and we have interactive tool which can assemble QSub instead of you, so you can use it for as an assembler, as I said. First of all, I would like to say that the main purpose of this presentation should be focused on the GPU cards, and before I will show you how our QSub assembler looks like, I would like to introduce this table, and this is the list of GPU nodes available on Metacentrum. And as you can see, we have various GPU nodes with different GPU cards, from some old GeForce card for up to very new and a lot of powerful A4, A40, A100 GPU cards. All of them are from NVIDIA, and yeah, probably that's it. There is some like additional information like a memory, compute capability, GPU CUDA versions, etc. I will tell you something about it later on. Now back to our interactive QSub assembler. I think it's a pretty nice thing. And on the left side, you can see how it looks like. So there is plenty of options which you can use, which you can set. I would like to point it out that most of them are dedicated for ordinary CPU jobs. So in the next few slides, I will show you just a couple of options, fields which you can edit and which are important for GPU calculations. Yeah, the most, let me say, important, necessary, essential parameters are on the first 2 lines, where you can set wall time. As I said once, it's how many hours do you want for a calculation. By default, the limit is 724 hours. If you need more, so we have to contact us and we will set it like individually. Then you have to select like some queue. We have a special queue for GPU jobs. I will tell you more about it on the next slide. Then you can select how many nodes do you want. Typical user needs just 1 node, but if you have a job which can very effectively be parallelized on more nodes, you can use more of them. Do you want a CPU? Yes, 1 to 10, depends on you. Do you want GPU cards? As I said, you can ask for up to 4 GPU cards in 1 node, because we don't have nodes where it's more than 4 cards. You can set some like RAM memory, scratch directory, etc., etc., etc. As I was talking about queues, it's a minus Q option. There is a list of queues which are available for each user, and again, most of them are dedicated for ordinary CPU jobs. But we have 3 queues which are dedicated to GPU calculations. And if you want to use GPU cards, your calculation must be submitted into one of these queues. So Metacentrum can offer you 2 queues. One is for short jobs up to 24 hours, and another one is a GPU queue for jobs longer than 24 hours. And as a bonus, as a member of Metacentrum, you have access to the resources of Supercomputing Center CERIT-SC, and there is another GPU queue, but only one, and for jobs shorter than 24 hours. So we can go back to the QSub assembler, and on the left corner, I just prepared some like a absolutely basic example how to reserve some resources. So meaning of this is that I want to 44 hours for my job, and it's 2 days. So it means that I have to use GPU long queue because this queue is dedicated for calculations longer than 1 day. I just want a 1 GPU card with a 20 gig of RAM memory, some space on a local scratch. And I think that's everything what I need for because I know that my calculations will be hypothetically very not special, so I don't need to set something more. And I have to let the assembler to assemble my QSub command. So it's like a click on that button, find machines matching the resources specification, and it will show me how the QSub commands can look like. First version is for a direct usage in a command line, and the second version, I don't know, can you see my? No, you can. And the second version, it's like where the hashtags are. It's a usage for batch scripts. I will show you both options later because I prepared 2 examples for you. One example will be like with interactive job. Another one will be with the batch job. And as a bonus, you can see which machines are suitable for your calculations, and you can see if some nodes are free right now and if your job can be executed immediately or will stay in the queue for a couple of moments. It depends on many, especially if how overloaded we are. And before we will continue, there is a couple of last like important things which should be say if you want to reserve some like a GPU calculation. So don't forget that even if you want super fast GPU card, still you need at least 1 CPU. So never forget to ask for one CPU, otherwise the PBS will kill your job. And what is important as well, that every calculation is unique, every tool is unique, every data set is unique, and there is no like equal mark that the newest, the fastest, the best GPU card is the best for all jobs. It's not true, and every user should verify which card is like optimal for his calculation. GPU cards cannot be shared, and every card is dedicated only to one calculation. And so again, user should optimize their calculations that the dedicated card should be maximally utilized. And if you want to monitor how your calculation is running nice or not, you can use command NVIDIA SMI on the same node where your calculation is running. From my experience, users it's quite often, they see that we have some very powerful like GPA cards, and they want them. So they specifically ask from a cluster where these cards are presented, and it can cause that jobs are queuing for a very long time. So if you want to, for example, select just a couple of like better nodes where better cars are present. So don't try to limit your calculation on a specific cluster. Just try to set it's quite better. Try to set another parameters like a GPU mem. It means that you want to card with memory bigger than, and now it depends what you write. You can set like a different GPU capability and or CUDA version. Everything is explained under that link on the right side. So now we can start with something a little bit more practical, and I prepared 2 examples for you. So let's start with the first one, and this first one example will be in the interactive job, and I prepared some brief introduction how to do base calling on Oxford Nanopore reads. I don't know what you are doing in your research, so I'm not sure if you know what base calling is, but in bioinformatics, base calling is a process how to determine nucleotides from electric signal. So basically it's a DNA or RNA sequencing. And for this example, I think we will show later if I was right or not. And I think that I need a GPU card with at least 20 GB of memory. I need some specific tool for this example. I need a GUPPY tool with the GPU support, and I need some small data set with input data. These data are in FAST5 format, just a specific format given by ONT technology. So as I said, we will use interactive job. So it means that we won't write some like a batch script. We will interact with the command line immediately in the real time. And first of all, what we have to do, we have to log in on some front end. So on this screenshot, you can see that I used my username and I used SHA protocol to log in on Infa front end. I type my password on the first try, so that's nice. And I'm there. I've been logged on. Now, I would like to check as a new user, I don't have experience, so I would like to check if there is software which I need, if this software is available in our modules, and if there is some like a normal version for you, is this software support GPU cards or not. So I can use module ava command and some keywords. For example, I can use like a GUPPY, it's a short name, so why not? So I typed it, press enter, and I can see that there is plenty of versions of GUPPY tool. Some of them are with CPU support, some of them are with GPU support. The latest version is 6.3.8, so yeah, I think it's fine for me and I can use it. Then, if I know that the application is suitable for me, I can run the interactive job. So it means that I have to use a qsub command to reserve some resources. And for interactive jobs, I have to write the capital I letter. It means like interactive. So, and can continue with the wall time. So I know that this test job will be short, so 4 hours should be fine for me. And as I said, I know I want to use a GPU card, so I have to specify a GPU queue. Then I want to just one node, so it means select this one CPU, one GPU card should be okay for me. Some RAM memory, space on the scratch disk, and as I said, I would like to use a GPU card where is more than 20 GB of memory of that card. So it's the last parameter, GPU underlined mem parameter. So if I type it, press again, and I will wait just a couple of moments when the resources will be given to my calculation. If it's done, my job is linked with some number, and I'm redirected to the computation, to the node. In this case, it was Galdor 4 node. So I asked for a scratch. I know that it's every time it's fine and it's beneficial for me to use scratch. So go to the scratch directory and copy there my input data which are prepared. Then I can load my module, and then, for example, I can call like binaries and ask for version if I want to check if this works or not. So I did it, and it told me that something version, yeah, everything it works, no error. It's a good start. So we can move on. And now it's a start to start. It's a time to start my own calculation. So I check the manual. I know what I want to do. So I specified some input, some output, and other parameters which should be interesting for me for my calculation. It depends. And again, hit enter, and it start doing something, producing some logs, and base calling. And after a couple of seconds, yeah, because this calculation was ultra super fast on a GPU card, everything was done, and base calling completed successfully. It sounds good, but in the meantime, I checked the status and the GPU utilization on that node via NVIDIA SMI command. So I opened another window, looked on the Galdor 4 node, type this command, press enter, and I can see that for my calculation, GPU card number 3 was given, and as I can see, the consumption of memory was 25 gigas. So this was 5 more than I wanted. So it was fine for me, because in this case I used a very powerful GPU card with 45 giga of memory, but so the reserve was quite huge. But on the small card, which has, for example, which can have, for example, 22 giga, so I should be in troubles, because the memory was not be enough. So when the calculation is done, I can check all outputs, and if everything seems to be fine, I should move my only output back to my storage. What I don't want to use anymore, I can remove it, and then just type exit and quit the interactive job. And that's basically everything. I did what I know, what I want to do. I have my results, so, and I can start with an analysis. Now we can move forward to the example number 2. We will do it in the classical batch. We will perform it as a classical batch job, and I've prepared for you some basic usage, how to use PyTorch for training with our singularity containers. So Metacentrum can offer you singularity, which is something like a Docker, but more suitable for grid computing. In this case, I will train the model on handwriting like letters, and what I need is a singularity. Singularity is installed on all nodes by default. I will torch, especially PyTorch, and and I don't need any special hardware, because I believe that this test is quite basic and not so hardware demanding. So the start is the same as in the case before. So look onto some front end, and now you have to write a shell script for your batch job. So you can just open some favorite like a text editor, and you have to write something like this. This is absolutely basic example how shell script for batch jobs can look like. So on the first 1, 2, 3, 4, 5 lines, you have to specify which parameters would like to get. So again, I want to use a GPU card, so I have to set my calculation to GPU queue. I need some wall time, so this calculation should be very fast. So I believe that 1 hour will be okay. 1 CPU, 1 GPU card. And here just for our a demonstration purposes, I decided to use like a GPU capability parameter, and I set it to the CUDA 69. So everything what we did before in the interactive job, we have to do it in the almost in the same way, but in this shell script. So you can set a lot of variables. So, for example, you can set variable scratch there, and you can check this variable is presented. You have to assume that yes, it will be created. So even within your bar job, you have to move to the scratch directory. Yes, if I will be there, so I have to download some data for my test purposes. So it's some zip file. I have to unzip it, and I have to move to the new location, change directory into that unzip file. I believe that everything will be fine. So I have to start my own PyTorch calculation. It's in Singularity. This looks like maybe a little bit complicated, but if you will check our documentation, it was a link on the slide before, so it's not so complicated. And I have to use the parameter CUDA that I want to use, like a GPU cards. That's what I am doing it. And finally, I have to set like utility clean scratch, and that's a thing which will clean the data in Scratch when the job is done instead of me. So I do not have to do it later on. So it will do it automatically. So if my shell script is done, I have to use like a qsub command to submit it to the PBS. So type it, press enter. My calculation is linked with some ID, and I have to wait a couple of minutes because this calculation was again super fast, faster than I expected, and I can see that some standard outputs have been perused. And if I will check them, I can see that everything was done, and I ask to do some 6 rounds of learning. I don't know. I'm not like a user of PyTorch, so I'm not really sure what was done. But end of training seems like a good message. There is no warning, no error message. All 6 rounds have been done, so I think that everything is fine, and that's it. If I should be like a more experienced user, no, basically there should be produced some output, some folder with some model trained. I have to incorporate it into my shell script for bar job, some another command which will copy or move that directory into my home and remove the rest of Scratch. And that's everything for me. So just like two examples, brief examples. And as I said, I don't know what are you doing, so I will be very, very glad if you can tell me what's your expectation and what you would like to do on MetaCentral. What are you doing for your research?